Hello everyone, this is Anik,
This is Muiz Khan.
and we are going to present our final project for the course Intelligent Systems. And the project title is Breast Cancer Classification Using Machine Learning Model. And in this project, we have used on dataset, which contains diagnostic breast cancer dataset, and we have applied five different algorithms to classify the dataset. So it's a binary classification. So we have decided whether it's a benign cancer or malignant cancer. So now we will go through our work in details in the presentation. However, this is a very brief presentation. Very details of our work is provided in the project report. So in this presentation, we will cover the following topics. So first, we will talk about the motivation of this work, and then we will introduce our work in brief. Then we will talk about the literature survey that we performed before starting the work. We will introduce the data set, its feature, and then we'll talk about the methodology we have applied. We'll talk about the result, discussion, and future work. So for the motivation, we know cancer is killing thousands of people every year, and breast cancer is one of the very common of them. But early diagnosis and also accurate diagnosis of breast cancer can help us to prevent death from the breast cancer. And a lot of research is being done in this domain, but none of them are very much like practical, and there is still a scope to improve accuracy. But in this project, our goal was to learn how to implement or achieve knowledge in this course for performing a classification based on given data. So we have done that, and that motivates us to work on this project. So in the introduction, breast cancer causes a death of a large number of people, and there are a lot of existing methods that diagnose breast cancer from X-ray images or other biomedical images. Um, but there is still a scope to work in this domain, this research domain. In this paper, we have applied five different machine learning algorithms to classify breast cancer, and that includes k-nearest neighbor and logistic regression. So these two model has given us the maximum accuracy, which is 97.99, and also the corresponding precision and recall value was good. So we'll see more details on the result section. So before starting this work, we went through several research, which is very relevant to our research idea, and we got some findings there. So that includes like various supervised machine learning classifier has been proposed for the breast cancer diagnosis. That includes the support vector machine, naive Bayes classifier, decision tree, and so on. So support vector machine showed a good performance among all those research, and ensemble learning has also been applied. But like there is still a scope to work, and our goal was to learn how to apply this data set on various model, and to compare methodologies and see how um, the parameters of the machine learning model reflects on the result. So very detailed survey has been provided on the report again. So the dataset we have used is called Wisconsin Diagnostic Breast Cancer Dataset, and this dataset doesn't have so many samples, but still it's decent. The count is 569 samples, and each of them has 30 features. So the data has two different class level, either it is benign or malignant. So this number of benign sample count was 357, and the malignant sample count was 212. So among the features, we tried to see the relationship with the target, and we found that the uh, radius, perimeter, and compactness, they were some most significant features that we figured out by performing some computations. So all of these features had numerical values. Now I will invite my teammate Muiz Khan to continue from here.
Thank you, Anik. So, as Anik mentioned, that this data set has 30 features, so it is quite a lot features to for the classifiers to classify. So we also learned about the curse of dimensionality. So we wanted to reduce this features by taking out the only the important features. So we performed KDEs, which is kernel density estimation, for all the features, and see that. And after performing this, we found these features are very important, which is radius mean, texture mean, perimeter mean, and so on. So all those important features were plotted in a pair plot for a better visualization, and we saw that these can actually separate the benign and malignant classes very well. And also, feature correlation matrix was presented in the paper, which actually presented a very good visualization how every of each of the features, 30 features, are correlated to each other. And as anticipated, some features such as radius mean, area mean, and so on, they showed a very good correlation among each other. About the methodology, as mentioned earlier, that we have used 5 different classifiers to classify the breast cancer dataset. So first, as an input, we took the breast cancer dataset from the WBCD website, and as this has a very large number of features, we selected a few features. Those are the most important by using the PCA, principal component analysis method. So as after running the PCA, we prepared our training data set, and we fed this training data set in each of the 5 different classifier models. And then we performed a voting mechanism, which is a soft voting mechanism, in order to identify the class labels. And this is an ensemble model, because we have combined different classifiers. So these are some results, and as we mentioned earlier, that logistic regression and KNN has the most accurate result, and their precision and recall values are also very acceptable. And we also see that SVM also performed very well. And during our literature survey, we also found that SVM performs really well in the binary classification. So this also proves that this is a very good classification method. For discussion, we can see some limitations, like this data set has only 700 plus objects, examples, which are not very much good for a machine learning model. So a machine learning model, to be generalized, it requires more data, a large amount of data. So robust data set will also, ensure the generalization of the model. So this is a limitation of this paper, of this work, of this data set. And for the future work, I think this model can be more robust by providing a very good prepared data, which can affect the classification directly. And the model can be trained with robust and diverse data to ensure higher accuracy and generalization. And graphical user interface based software can be developed based on the machine learning model, so that the end user end level user can use this model. So that's pretty much it. Thank you for this amazing opportunity to participate in this course. And if you have any questions, these are emails, so you can reach out to me or my teammate. So thank you.
Thank you, Professor.